You're welcome to solve this nice algebra problem, which is the square root of c plus c, this is equal to 6. So what is the value of c? Now solution from here, we have that the square root of c plus c, this is equal to 6. The first step here, let's take c on the right hand side, so that we'll have square root of c, this is equal to 6, subtract c. So the next step here, let's square both sides here. Let's square both sides so that now the square root of c squared will eliminate the square root sign. So here we have c, this is equal to 6 minus c squared. Now we can express 6 minus c squared as 6 minus c multiplied by 6 minus c. So this is the same thing as 6 multiplied by 6 minus c, subtract c multiplied by 6 minus c. Now in this case, we have c is equal to 6 times 6, this is 36, subtract 6 times c, this is minus 6c, subtract, now we have negative c times 6, this is minus 6c, then minus 6 minus c times minus c, this is plus c squared. The next step from here, let's take this c on the right hand side, this is plus c, so on the right hand side this becomes negative. So what we have here, this is c squared, subtract, this is minus 6c, this is minus 12c, subtract this c, then plus 36, this is equal to 0. So here we have c squared minus 12c minus c, this is minus 13c, plus 36, this is equal to 0. Now this is a quadratic equation of the form ac squared plus bc plus c, this is equal to 0. Now from what we have here, we have a equal to 1, b equal to minus 13, and c equal to 36. So we can solve this quadratic equation by applying factorization, by applying the factorization method. In this case, we have the sum here. The sum in this case is negative 13, and the product is actually equal to 36. So now we have to identify two factors such that the summation of those two factors will give us negative 13, and the product of those two factors will give us 36. Now these two factors are negative 9 and negative 4. So we have these two factors. So let's proceed. So by applying the factorization method here, sum is minus 13, product is 36, factors here we have minus 9, minus 4. So we say minus 9 plus minus 4, this is equal to negative 13. So these factors satisfies the sum. When you say negative 9 times minus 4, this is equal to 36. So these two factors satisfies the sum and the product. So let's substitute these two factors in the quadratic equation. So we have c squared minus 9c minus 4c plus 36. This is equal to 0. And therefore from here, we can factor out c. C is common here. Let's factor out c. So we'll have c minus 9. Subtract, this is 4c plus 36. So here 4 is common. So we factor out 4. We'll have c subtract 9. This is equal to 0. So now we have here, you can see we have c minus 9 and c minus 9 here. So we have c subtract 4 And then here we have C minus 9. This is actually equal to 0. So in this case, we have two parts here. We have C minus 4. This is equal to 0. And we have that C minus 9. This is equal to 0. So we have two possible values of C. We have C1 is equal to 4. And we have C2, this is equal to 9. So we have C1 equal to 4 and C2 equal to 9. So the next step here is to verify. The next step is to verify that C1 and C2 satisfies the equation. Now, if you recall, we entered the square root of C plus C. This should give us a value of 6. So substituting C1 here is equal to 4. Let's substitute here so that we'll have square root of 4 plus 4. This should give us a value of 6. Let's check if this is true. Square root of 4 here is 2 plus 4. This is equal to 6. It's true that 2 plus 4, this is equal to 6, which is equal to 6. So that implies that the left-hand side is equal to the right-hand side. So let's check C2. Let's verify C2. So let's verify that C2, which is 9, actually satisfies the equation. So here we'll have the square root of 9 plus 9. Let's check if this is equal to 6. So square root of 9, this is 3 plus 9, and this is not equal to 6. So 3 plus 9, this is 12, which is not equal to 6. And that implies that C2 does not satisfy. This one does not satisfy the equation. So C2 is rejected. And therefore, we only have one solution, which is C1, which is actually equal to 4. We have only one solution. We only have one solution. So thank you for watching. Kindly follow the steps, like this video, and subscribe. See you in the next video.